E is equal to mc squared. It's probably the most famous and interesting equation in physics. This equation was discovered by Einstein. I believe that there isn't any science student who doesn't have heard of this equation. But do you know from where this equation has come? If the answer is yes, thumbs up. But if you don't know, watch the full video and don't forget to subscribe the channel. E is equal to mc squared. Here E represents energy, m is mass and c is the speed of light, which is 3 into 10 to the power 8 meter per second in empty space. Now, as speed of light is constant, we can say that E proportional to m, but not equal. That means if an object can travel at the speed of light, it will become energy. I know that it hears very odd, but that's true. But in reality, photons are the only objects in nature which shows this property. Well, that was the introduction of E is equal to mc square. Now prove it. Let's take that there is a ball in empty space with no outer force acting on it and you are watching it. Suddenly it emits an exact frequency of light. That means it loses energy. Assume that the amount of energy is E. As the light is coming out from the particle symmetrically, that means its velocity will not change. But from where the energy comes? Never mind that now. Let's imagine that you board your spaceship and zoom off in space at the middle of the experiment. So that means the ball is moving at a velocity, but according to relativity, you are sitting still in your spaceship and the ball is the only thing which is passing out of the spaceship. So it has some kinetic energy which is Ke, and when the ball emits certain frequency of light, it loses energy E. Now, according to relativity, time passes in different rates from different perspectives. So, the energy E will be different from your perspective. It is called Doppler effect. So, in case of energy, E is E multiplied by 1 plus relative velocity v squared by 2 into speed of light c squared. So, in this experiment, there are two different perspectives. At first, you are traveling by your spaceship, so you are seeing that the ball is moving with kinetic energy Ke1, and then it emits light and loses energy which is E into 1 plus v square by 2c square. On the other hand, you can see in second case, you are observing the ball which is sitting still and the ball emits energy E. That means its energy decreased down by E, and then you start to move and the ball gets kinetic energy Ke2. But in both cases, the ball wasn't influenced by you. So according to conservation law of energy, in both cases the final amount of energy is same. That means Ke1 minus E into 1 plus v square by 2c square is equal to Ke2 minus E. Now kinetic energy is equal to half into mass into velocity square. As the velocity in both cases are same, that means the difference between kinetic energies is the mass in two cases. Now if we cancel all these things out, we will see that the change in mass is equal to the energy emitted divided by the speed of light square. That is E is equal to mc squared. But that's not the end of this equation. It has another part. But today I'm not extending the video. Thanks for watching. If you like it, give a like to the video.